In this video, we will look at the knapsack problem, also known as fractional knapsack problem. The knapsack problem is solved using the greedy method. In the knapsack problem, we have a set of n objects. For example, let us consider we have 3 objects and a knapsack. Each of these objects has weights associated with them. The weight of each object is represented by W. So let us consider W1 as the weight of object 1, W2 as the weight of object 2, and W3 as the weight of object 3. Then we also have profits associated with each object. The profit of each object is represented by P. So let us consider P1 as the profit of object 1, P2 as the profit of object 2, and P3 as the profit of object 3. Then we have the capacity of the knapsack represented by M, that is the maximum weight the knapsack can carry. The knapsack problem is to fill the knapsack with the objects that maximizes the total profit. This is known as the objective function. Let us consider an example. Let us consider we have 3 objects. The weight W1 of object 1 is 18 kgs and the profit P1 of object 1 is $25. The weight W2 of object 2 is 15 kgs and the profit P2 of object 2 is $24. And the weight W3 of object 3 is 10 kgs and the profit of object 3 is $15. Now here, as an example, we are using weights in kgs, but the weight can be gallons, liters, or the weight can be in any unit, or we just simply say that W1 is 18, W2 is 15, and W3 is 10, without specifying the unit of measurement. In the same way, the profit we are using is in dollars, but the profit can be in any currency, or we just say that P1 is 25, P2 is 24, and P3 is 15 without specifying the currency. Then let us consider the capacity M of the knapsack is 20. Now the knapsack problem is to fill the knapsack with the objects that maximizes the total profit. To do this, we can fill the knapsack with any of the objects, but the weight of the objects in the knapsack cannot exceed the capacity of the knapsack. This is the constraint of the knapsack problem. So we will look at the first greedy strategy of selecting the objects according to the decreasing profits. Therefore, we will select object 1, which has the highest profit. The weight W1 of object 1 is 18 and the capacity M of the knapsack is 20. Therefore, the knapsack can be filled with whole of object 1. Now, once the knapsack is filled with object 1, the remaining capacity of the knapsack will be M minus W1, which is 20 minus 18. So, the remaining capacity of the knapsack will be 2. Then, the question is, can we fill the knapsack with object 2, since it has the next maximum profit? The weight W2 of object 2 is 15, and the remaining capacity of the knapsack is 2. Therefore, the knapsack cannot be filled with the whole of object 2. Similarly, the weight W3 of object 3 is 10, and the remaining capacity of the knapsack is 2. Therefore, the knapsack cannot be filled with whole of object 3. But since there is some capacity left in the knapsack, so the knapsack can be filled with some part or portion of object 2 or object 3. So if we consider object 2, the weight of object 2 is 15 and the remaining capacity of the knapsack is 2. Therefore, the knapsack can be filled with 2 by 15th fraction of weight W2 of object 2. Now, the remaining capacity of the knapsack will be 2 minus 2 by 15 multiplied by 15. So, the remaining capacity of the knapsack will be 0. Then, since the remaining capacity of the knapsack is 0, therefore, no other object or objects can be used to fill the knapsack. So, if the weight of the object is less than or equal to the capacity or the remaining capacity of the knapsack, then we can fill the knapsack with the object. Otherwise, we consider that the objects are divisible and we can fill the knapsack with some fraction of the weight of the object. Now, as the weights are represented by W and the profits are represented by P, the solutions are represented by X. So, in this case, the knapsack is filled with whole of object 1. Therefore, the solution x1 of object 1 is 1 because the whole of object is used to fill the knapsack. Then, the solution x2 of object 2 will be 2 by 15 because that is the fraction of the weight W2 of object 2 which is used to fill the knapsack. Then the solution x3 of object 3 will be 0 because the knapsack is full and object 3 or fraction of object 3 cannot be used to fill the knapsack. So the solution x1 is 1, x2 is 2 by 15 and x3 is 0. Now this solution should satisfy the constraint. That is, the summation of product of weights W and fractions X must be less than or equal to the capacity M of the knapsack. If the solution X1, X2 and X3 satisfies this constraint, then the solution is feasible. So, we have the product of W1X1 plus W2X2 plus W3X3, that is 18 multiplied by 1 plus 15 multiplied by 2 by 15 plus 10 multiplied by 0, which is 20, and is less than equal to M, which is also 20. So the constraint is satisfied, and since the constraint is satisfied, we say that the fractions x1 equal to 1, x2 equal to 2 by 15, and x3 equal to 0 is a feasible solution. Then the total profit earned will be summation of the product of profits P and the fractions X. So the total profit earned for this feasible solution is product of P1x1 plus P2x2 plus P3x3, that is 25 multiplied by 1 plus 24 multiplied by 2 by 15 plus 15 multiplied by 0, which is 28.2. Now, this is one of the feasible solutions among multiple solutions. The objective is to earn maximum profit. So, the fractional weight of each object selected should maximize the total profit earned. Now, let us find another solution using the greedy strategy. That is, we will pick the objects according to increasing weights, such that we can pick as many objects as possible. Therefore, we will select object 3, which has the least weight. The weight W3 of object 3 is 10, and the capacity M of the knapsack is 20. Therefore, the knapsack can be filled with object 3, and the solution x3 will be 1, since the knapsack is filled with whole of object 3. Now, the remaining capacity M of the knapsack will be M minus W3, which is 20 minus 10. So, the remaining capacity of the knapsack will be 10. Then, the question is, can we fill the knapsack with object 2, since it has the next least weight? The weight W2 of object 2 is 15, and the remaining capacity of the knapsack is 10. Therefore, the knapsack cannot be filled with whole of object 2. But since there is some capacity left in the knapsack, so the knapsack can be filled with some part or portion or fraction of object 2. So, if we consider object 2, the weight of object 2 is 15 and the remaining capacity of the knapsack is 10. Therefore, the knapsack can be filled with 10 by 15th fraction of weight W2 of object 2. So, the solution x2 will be 10 by 15, since 10 by 15th fraction is used to fill the knapsack with object 2. Now, the remaining capacity of the knapsack will be 10 minus 10 by 15 multiplied by 15. So, the remaining capacity of the knapsack will be 0. Then, since the remaining capacity of the knapsack is 0, therefore, no other object or objects can be used to fill the knapsack. So in this case, the solution is x1 is 0, x2 is 10 by 15, and x3 is 1. Now this solution should satisfy the constraint, that is, the summation of the product of weights w and fractions x must be less than or equal to the capacity m of the knapsack. If the solution x1, x2, and x3 satisfies this constraint, then the solution is feasible. So we have the product of w1 x1 plus w2 x2 plus w3 x3, that is 18 multiplied by 0 plus 15 multiplied by 10 by 15 plus 10 multiplied by 1, which is 20, and is less than equal to m, which is also 20. So the constraint is satisfied, and since the constraint is satisfied, we say that the solution x1 equal to 0, x2 equal to 10 by 15, and x3 equal to 1 is a feasible solution. Then the total profit earned will be summation of the product of profits p and the fractions x. So the total profit earned for this feasible solution is product of p1x1 plus p2x2 plus p3x3, that is 25 multiplied by 0 plus 24 multiplied by 10 by 15 plus 15 multiplied by 1, which is 31. Even now, we cannot say that the feasible solution which gives the profit of 31 is the optimal solution because there may be numerous feasible solutions. Therefore, we will look at another greedy approach which gives us the maximum profit. We will use the greedy strategy of selecting the objects according to decreasing ratio of profit by weight. Therefore, for all the objects, we will compute profit per unit weight, that is, the ratio of profit by weight. So, for object 1, the profit is 25 and the weight is 18. Therefore, ratio of profit by weight is 25 by 18, which is 1.39. The ratio of profit by weight for object 2 is, the profit for object 2 is 24 and weight is 15. So, the ratio of profit by weight is 24 by 15, which is 1.6. And the ratio of profit by weight for object 3 is, the profit for object 3 is 15 and the weight is 10. So, the ratio of profit by weight is 15 by 10, which is 1.5. So in this case, we will select object 2, which has maximum profit by weight ratio, that is 1.6, and we will fill the knapsack with object 2. The weight W2 of object 2 is 15, and the capacity M of the knapsack is 20. Therefore, the knapsack can be filled with whole of object 2, and the solution x2 will be 1. Now, the remaining capacity of the knapsack will be 20 minus 15, that is the weight of object 2. So, the remaining capacity of the knapsack will be 5. Now, since there is some capacity left in the knapsack, so the knapsack can be filled with some part or portion or fraction of other objects. So, we will consider object 3 since it has the next highest profit by weight ratio. The weight of object 3 is 10 and the remaining capacity of the knapsack is 5. Therefore, the knapsack can be filled with 5 by 10th fraction of weight W3 of object 3. So, the solution x3 will be 5 by 10. Now, the remaining capacity of the knapsack will be 5 minus 5 by 10 multiplied by 10. So, the remaining capacity of the knapsack will be 0. Then, since the remaining capacity of the knapsack is 0, therefore, no other object or objects can be used to fill the knapsack. So, in this case, the solution x1 is 0, x2 is 1, and x3 is 5 by 10. Now, this solution should satisfy the constraint, that is the summation of the product of weights w and fractions x must be less than or equal to the capacity M of the knapsack. If the solution x1, x2, x3 satisfies this constraint, then the solution is feasible. So we have the product W1 x1 plus W2 x2 plus W3 x3, that is 18 multiplied by 0 plus 15 multiplied by 1 plus 10 multiplied by 5 by 10, which is 20, and is less than equal to M, which is also 20. So the constraint is satisfied, and since the constraint is satisfied, we say that the fractions x1 equal to 0, x2 equal to 1, and x3 is 5 by 10 is the feasible solution. Then the total profit earned will be summation of the product of profits P and the fractions x. So the total profit earned for this feasible solution is product of P1x1 plus P2x2 plus P3x3, that is 25 multiplied by 0 plus 24 multiplied by 1 plus 15 multiplied by 5 by 10, which is 31.5. And since this feasible solution gives us the maximum profit, therefore this is also an optimal solution. So this is how knapsack problem can be solved by using the greedy method by selecting the objects in the decreasing ratio of profit by weight to achieve maximum profit. Now let us look at the knapsack algorithm. This algorithm is called greedy knapsack and takes two parameters, that is M, which is the capacity of the knapsack, and N, which is the number of objects. It is assumed that the profits and weights of the objects are given and objects are arranged in decreasing order of the ratio of profit by weight. Then, within this algorithm, the very first thing is to initialize the solutions. So, we will have a for loop from 1 to n and initialize all the elements of the array x to 0. The array x will be storing the fractions or is the solution. Then we will use a variable u and initialize it to m, which is the capacity of the knapsack. This variable u is used to keep track of the remaining capacity of the knapsack. Then we need to select one object at a time. So we will have a for loop from 1 to n, and within this for loop, we will first check if the object can fit in the knapsack. So we will have the if statement with the condition weight of the object, that is w of I, is greater than u, which is the remaining capacity. If this is true, that means the weight of the object is more than the capacity, and the object cannot fit in the knapsack, and we will break from the for loop. Otherwise, it means that the weight of the object w of I is less than the remaining capacity, and whole object can fit in the knapsack. So, we will assign the fraction or solution xi as 1. Then, since the whole object is placed in the knapsack, so the remaining capacity of the knapsack will change. So, we will subtract the weight of the object w of I from the remaining capacity u using the statement u assigned u minus w of I. Now, this for loop will place all the objects that can fit in the knapsack according to the capacity of the knapsack. Then, there may be some capacity remaining in the knapsack. So, we will check if there are any objects left that can be placed in the knapsack using the if statement with the condition I less than equal to n. If this is true, that means there are some more objects left that can be placed in the knapsack. So, within this if statement, we will assign the fractional weight of the object, since the whole object cannot be placed in the knapsack, using the statement x of I assigned u, that is, the remaining capacity divided by the weight of the object w of I. So this is the greedy knapsack algorithm, which takes the input as the capacity m of the knapsack, the number of objects n, which are arranged according to decreasing ratio of profit by weight, and returns the solution array x. Now let us analyze this algorithm. The first statement is the for loop, and this for loop will execute for n plus 1 times. Then the next statement is the primitive statement and will be taking constant time. Then we have another for loop, and this for loop will also execute for n plus 1 times. And the other statements are primitive statements. Therefore, the overall complexity of this greedy knapsack algorithm is O of n. Remember, we have assumed that the objects are sorted in descending order of profit by weight ratio. This sorting will be taking O of n log n as the time complexity. Now, before we conclude, let us summarize the knapsack problem. There are n number of objects and a knapsack with capacity m. Each object has weight and profit associated with them. If a fraction xi of the object is placed in the knapsack, then profit pi xi is earned. The objective is to maximize the profit earned subject to the condition that the total fractional weights of the objects is less than equal to the capacity m of the knapsack. The fraction x is in the range 0 to 1 and I is in the range 1 to n. The greedy strategy to be applied is to select the object in non-increasing or decreasing order of the ratio of profit by weight. And this greedy strategy will result in earning maximum profit. The overall time complexity of the greedy knapsack algorithm is O of n. So, this is the knapsack problem which is solved using greedy method to earn maximum profit.